Greetings, everybody. Learning is a hobby here. In this video, I want to go over the solutions to section 1.1 in Serge Lang's Geometry, a high school course. So let me bring up my solutions and we'll go over them. And also, I should say, I want to illustrate a nice new feature of Desmos too when we get to uh, the construction problems. So, but let me bring up my notes here. Okay, so there's two parts to the exercise set. I don't know if this is true in general, but at least for section 1.1 it is. You have some problems here, and then there's another set of problems that have to do with construction, uh, compass and straight edge and ruler constructions. So let's go through the first set of the first exercise set, and then we'll go over the constructions afterward. So here we go. This is for section 1.1. Question one says, illustrate each of the following by labeling 2 points on your paper P and Q and drawing the picture. So here they want us to draw the line that passes through the points P and Q. All right, so that's what it looks like. You guys know what a line looks like. But I think that Lang is just getting us used to the notation here. Here we have a ray QP. So the vertex of the ray is Q, and we want the ray to pass through the point P. So I have that drawn here. Part C, they want us to draw the line segment PQ, which I have drawn there, as you can see. Then we want ray from P to Q. So here P is the vertex and Q is some other point on the ray. And I have it drawn here. All right, question number two. Draw 3 points, M, P, Q, and draw the rays RPM and RPQ. Under what conditions will these two rays together form a whole line? So here I have drawn the picture. For these two rays to form a whole line, MPQ must be collinear with RPM not equal to RPQ. In other words, P has to be between M and Q in order for it to be a straight line, in addition to the 3 points having to be collinear. All right. Question three, suppose points PQM lie on the same line as illustrated in the figure below. Write an equation relating DPQ, DPM, and DQM. That stands for distance between P and Q, distance between P and M, and distance between Q and M. And here, obviously, the equation is that the distance from P to M is equal to the distance from P to Q plus the distance from Q to M. All right, question four, by our definitions, is the line segment AB parallel to the line segment PQ? The answer is no, because the lines that contain AB and PQ are not parallel. All right, so here, we're just using the definitions that were gone over in the chapter. Question five, criticize the following statement. The line segments connecting any 3 points in the plane make up a triangle. And here's my solution. The line segments connecting three collinear points do not make a triangle. So that's the criticism. All right, question six. In the figure below, line K is parallel to line U, and line L intersects line K at point P. What can you conclude about lines L and U? And Lang wants us to say why. So here's my solution. L and U are not parallel, since if L is parallel to U and U is parallel to K, that implies L is parallel to K by par 3, and clearly L is not parallel to K. Therefore, L cannot be parallel to U. All right, question seven. In figure 1.3a, which I have drawn down below, we have drawn a picture illustrating part 2, where point P is not on the line L. Explain how part 2 is still true even if P does lie on the line L. All right, so here's my answer. The fact that L is parallel to itself does not contradict part 2. If there were another line K with K not L that has the property that P is a point on K, then K is not parallel to L, since parallel lines that are not equal do not intersect. Okay, and then here we get to the construction problems, which is the part that I'm looking forward to the most, I think, in the geometry book. But here we go. This is construction one. So here's Lang is outlining how to construct a triangle with three specified sides. So we'll go through the procedure here, and then the problems that we're going to look at all deal with this type of construction. So to construct a triangle given the lengths of the three sides, you are given segments A, B, C, D, and E, F, which is drawn in figure 112 that I have down below. And if you wish to construct a triangle whose sides have lengths equal to the length of the three segments, then here's the process. Draw a line on your paper. Set your compass at a distance equal to the length of AB. Choose a point P on your line. Place the point of the compass on P and draw an arc which crosses the line at point Q. Set the compass tips at a distance equal to the length of CD. Place a tip on P and draw an arc above the line. Set the compass equal to the length of EF. Place a tip on Q and draw another arc crossing the previous one. Where these arcs intersect is point R, and triangle PQR is the desired one. All right, so here are the exercises that deal with that type of specific construction. All right, so question one says this: construct a triangle with sides equal in length to P, Q, R, S, and XY. He has a picture drawn in figure 114. Now, let me just stop the screen share for a second. So I was experimenting with different ways of showing you guys how to do the constructions. I have a physical compass and a ruler and a straight edge, but with the way that my camera set up is, it didn't show up very clearly on the video. So I was looking for other ways of illustrating constructions to you using, the computer. And actually, I want to show you a nice feature that Desmos has now. You can actually do geometric constructions on Desmos. Let me show you how to do that. So I'll share my screen. Okay, so if you go to the Desmos website and click on Math Tools, there are a bunch of options here. So you can use your graphing calculator. There's a scientific calculator, a four-function calculator. I haven't looked at test practice, but I guess that's an interesting feature. Maybe you can practice for tests, on different subjects. Then there's a matrix calculator, which is awesome because now you can do matrices on Desmos. There's also a geometry tool, which I'm going to show you in a second, but there's also a 3D calculator, which is relatively new, which is neat. So if you haven't, signed up for, created an account for Desmos, you should do that and play around with it because there's a lot of cool stuff that you can do on here, and it's completely free. So it's a useful tool to have. So I'm going to click on the geometry tool. Right, so click on this, and now I'm going to do the triangle construction that um, Lang asks us to do. So let's say I'm just going to draw three different lines. Line segments. So what you do is you take segment here, click on that, and then you can draw. See if I'll do it down here so I can maybe fit it in up above. So I'll draw one line segment here. Oops, can I move this down? Maybe I'll do a line segment that looks like that. Let me see if I can zoom in and out. Okay, and then I'll have another line segment maybe that looks like this. And I want to make a triangle out of these, that has these segments as its side. So what I can do is I can take the segment that I have drawn over here, and I can go to the circle option here and go circle by length. And I can click on this, and it'll give me a circle that has the length of that line segment, and I can move it up here, right? Then I can go to this line segment, make a circle that has that. Oh, I have to make a bigger circle. How do I, hang on, let me make a different segment. How do I erase this? Sorry, I just found out about this 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 feature, so I haven't really had a chance to play around with it. Sorry, I don't want a line, I want a segment. I haven't had a chance to really play around with it too much yet. So segment, I need a longer segment here. Let's say something that looks like that. Okay, so now I'll go back to circle by length. and click here and move the circle up here. Click on this, move this circle over here, and then we'll have, let's click on line segment again. Let me actually zoom in a little bit so it's easier to see. So what I'm going to do now is I'm going to connect this point to the point where the circles intersect, and same thing over here. And that gives me a triangle that has the required, lengths for the sides. So that's the construction. All right. So that's question number one. Let me go back to the problems here. All right. Then for question two, Lang says construct a triangle whose sides are 5 centimeters, 7 centimeters, and 10 centimeters. So here we're actually using specific lengths. So to do this problem, I'm actually going to go to the graphing calculator, because then we have, units defined on the axes. So let me go back to Desmos and we'll do that one. Right, so I have that drawn here. Let me actually get rid of this stuff first so you can see how the construction goes. Okay, so first thing is I have my line segment here drawn in red. This has length 10, so we wanted 3 line segments that had lengths 5, 7, and 10. So I just drew the longer one on the bottom there. Okay, and then I can draw a circle, use the construction process to find to draw a circle of length, sorry, that's a circle of radius 7, centered at the origin at 0, 0, which I guess you could call P, and the endpoint at 10, 0, Q. All right, and that gives me this half. You don't have to draw the whole thing, just draw part of the circle, and then draw the circle centered at 10, 0 that has radius 5, and that looks like this. And then notice that the point where they intersect is this point here, and I can connect the endpoints together to get a triangle that has the specified side lengths. Okay, so that's question two. Let's see what question three wants us to do. All right, for question three, choose one of the segments in problem one and construct an equilateral triangle whose sides have the same length as that segment. All right, I could do that back on the construction part of Desmos. Just bear with me while I share the screen. Okay, so let me undo what I had drawn here. Let's see, oops, let me see if is it possible to move this? All right, I'm just going to draw another line segment here. So let's say we have that line segment, and then I'll draw another one. Okay, that looks like that. I'm just, doing it at random. Then I'll make a circle. Oh, I'm sorry, they wanted an equilateral triangle, didn't they? So I don't actually need a second length. I can just do this. So go to the circle, click on length, and I'll draw 2 circles that have, that have the same, let's have the same radii. Uh, there we go. And then I will connect, sorry, I don't want line, I want line segment. Hopefully I'll get better at using this as we go along. Like I said, I just discovered this tool. So, all right. And then there we have our equilateral triangle. All right. So that's the answer for question three. All right, let's see what they want for question 4. Construct a triangle such that one of the sides has the same length as PQ, while the other two sides have the same length as RS. All right, so we can, in other words, they want us to draw an isosceles triangle. We could do that here as well using Desmos. All right, so let me redo this. All right, let's make another line segment. Right, I'm just making something at random because obviously I can't copy the actual line segments from the book. Okay, so now let me whoops, I don't want circle. I want circle by length. Okay, I'm going to make a circle that has radius equal to that second line segment. Put it here, center it here. Whoops, not that one. Right, center this here, and then I can draw another line segment going from here to this, and then this to here. And that gives me an isosceles triangle. Okay, so that's the answer to that question. All right, question 5. Construct a triangle whose sides have length 5 centimeters, 7 centimeters, and 15 centimeters. So again, I did this on Desmos already. All right, so let me see. That's this one here. All right, so first off, I have, oops. So here I have my line segment of length 15, drawn in red on the x-axis. And if I draw circle of length 7 and a circle of length 5 centered at the endpoints, this is what the picture looks like. And notice that the two circles actually don't intersect anywhere. So here you don't actually get a triangle because the lengths are not big enough to sort of, you know, connect together to form a triangle. All right, going back to the problems. All right, so that's question 5. Question 6, can you explain why there is trouble with problem 5? And the problem is that 5 plus 7 is less than 15. That's why it doesn't work. All right, question 7, draw any triangle just using a ruler and measure the length of the 3 sides. Add up the lengths of any 2 sides and compare this total with the lengths of the third side. And what do you notice? So clearly, you guys should know the answer to this, and it's clear from the problem that we just did. What you need in order to get a triangle is for the sum of the lengths of 2 of the sides to be greater than the length of the third side. All right, question 8, construct a triangle with sides of length 5 centimeters, 10 centimeters, 15 centimeters. And they want to know what Lang wants to know what happens. So again, I did this on Desmos already. Right, so let me actually do that here. So again, we have our line segment of length 15. If I draw a circle with radius equal to 10 centered at the origin, and I draw a circle of radius 5 centered at 15, 0, then this is what it looks like. So notice here that we don't get a triangle because the point of intersection of the two circles lies on the red line already. So, the sum of the two lengths actually add up to the length of the third side. So in this case, the points are collinear, that you don't get a triangle. Right, and I think there's one question left in this section. Question number 9, let P, Q, and M be 3 points in the plane, and suppose that the distance between P and Q plus D the distance between Q and M equals the distance from P and M. What can you conclude about points P, Q, and M, and draw a picture? What we conclude is that the points are collinear, and we've already actually seen a picture in question number 8, so you can see why that is the case. And that's the exercise set for section 1.1. So let me stop my screen share. Let me know what you guys think about the Desmos application down below. I have to fiddle around with it to learn how everything really works. I just discovered it, but I'm glad that they have an actual geometry tool now available for free on Desmos. So yeah, and just in general, let me know what you think down below, and I'll be continuing with Lang's 2 high school level books until we finish them. This is the beginning of my series on Lang's textbooks. All right, I'll see you guys in the next one.